The first thing you will need for optimization would be installing Solver on your Excel. So make sure under the data tab you have this solver available to you, but then if not, you'll have to first install it by going to File, Options, and then go to Customize ribbon. And on the right hand side, there's a chance that you don't have developer checked yet. Then go check your developer and say OK, and you will have developer tab available to you. Then go to Excel add-ins, just click everything that you see and say OK, all right? After that, if you come back to data, there you will have another section with solver and perhaps data analysis together made visible to you. Now let's come back to our main analysis where we have to do optimization. So our goal here would be to figure out the maximum NPV values that you could create with a combination of the projects available to you, but still keeping the total cost below our constraint level of $3 million. All right, so we first need to figure out the total costs of the projects and also total NPV amounts. And at the end of the column, we will still want to have the sum of all the ones. So what these ones indicate is that this particular project is included in your investment list. If it were 0, then it would indicate that it's just excluded from your list and that project is not selected. Let's try to figure out the total cost first. The function you need here would be sum product. You're making a multiplication of two arrays here, which is the cost and also the ones. And why don't you put dollar signs before the array so that the last column is fixed. And the total cost here, if we include every project in your investment list, then the total cost would be $7.6 million. With this, why don't you copy it to the last cell, fill without formatting, and then you will see on your row 18 that tell you if you included all the projects from A to M, the total cost would be $7.6 million. Your NPV total will be 763,000, and the number of options available to you at the moment is 13. All right, but you notice that your total cost is way above your capital constraint, which is not an optimal choice at all. So given that, if you wanted to make your choice that will give you maximum NPV possible with still keeping total cost under your constraint level, you'll have to get help from Solver. So Solver, your goal here again is to make your NPV, total NPV, maximized by changing your include or ones here. Remember how I said this indicates whether this project is included or not. So here our changing variable that proxies whether this project should be included or not. And you have to have two constraints here. First constraint is obviously something that has to do with your total costs. So you want your total cost to be below your constraint level, which is given in your cell 19, 3 million, right? So this is the first constraint that you want to meet. Say okay, right? And the second constraint here would be include the proxy of inclusion. So we want those proxies to be binary variables, so that one indicating included, 0 indicating excluded. Say okay. So you have your objective function, you have your changing variable, and also your constraints. And the solving method you will use here is SimpleXLP, which is a linear model. You want a linear model here, and perhaps you can leave it unmarked. It would be better that way. And just if you think you're ready, click solve. And you will see it has just conducted the maximization process for you. And keep solver solution. And as you can see, the total cost is under the constraint of $3 million. And NPV amount that you find here should be the maximum NPV amount that you should have. And what you notice here is, your ones are no longer just a column of ones, but it sometimes have zeros. What these zeros indicate is all these variables are just excluded from your list. But the ones that have ones, like A, C, D, F, H, and L, all these 6 variables are part of your investment list.